This is the fifth decay process, that is called the gamma decay. And gamma decay are emitted to relieve the nucleus from its extra energy burden that is carries in its state of the excitation. So if there is the simple explanation of the gamma decay is, if there is no alpha decay, positron emission, or the neutron emission, or the electron capture, but the nuclide is still unstable or present in the excited state, then they should emit the energy, and energy in the form of the gamma rays to get themselves stabilized. So actually these are called the isomers to each other, and they are called the isomeric states. And this is also called the metastable states and denoted by the small m, and which is mentioned with the mass number. So this is cadmium 115M. That means this is having the unstable nuclide having some sort of the energy, and this energy should be released in the form of the gamma rays, and then it will be converted into the lower energy state, that means the more stable state. So there is no change in the atomic number and the mass number in case of the gamma decay. So this is very important to note over here. So gamma decay generally be released by the internal conversion. Again, let's suppose this is the mercury. Mercury, if it is emitting the beta decay and converted into the TL nuclide, and again atomic number is going to increase, that means this is the neutron emission. So neutron emission, there is an increase in one atomic number. So what would be happened over here? Look at the state over there. Or this is the atomic number 81203, and this is the TL nuclide having the same atomic number and the mass number. But what will be the difference? This is at present at the excited state. This is at the ground state. That means now the energy is released in the form of the gamma rays, and this nuclide parent is converted into the daughter with the least energy, and this is called the gamma ray emission. So this is another representation. This is the same nuclide which is mentioned over here. After emission of the neutron, now they are going to be release the gamma rays by the internal conversion from which is being uh, converting from its nucleus, and then step by step it is moving outward and then relieving out of uh, the extranuclear part. Again, this gamma rays, if it is having sufficient energy while the internal conversion, during the internal conversion, then it also has the ability to remove the electron from the K shell. And if it is remove the electron from the K shell, again there is a vacancy. To fulfill this vacancy, this electron from the L shell is moving towards the K shell, and the difference in energy is released, that is called the X-ray energy. So it depends on the energy of the gamma rays. If it is having sufficient energy, then it can remove the electron. Otherwise, it can be internally be released in the form of the gamma rays. So this is all about the gamma decay.